Hi, I'm Emily from emilylearning.com, and in this video I'll be going through the paper 4 of the Cambridge International A-Level Math paper. This is from May-June 2024. Okay, so this is a mechanics paper, so let's take a look at it. In question 1, you're told that a car starts from rest and accelerates at 2 meters per second square for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds. So you're asked to sketch a velocity time graph for the motion of the car. So we know that we are supposed to sketch a velocity time graph, right? So let's write this as V and this is T. And time is in seconds while velocity is in meters per second. Now, the car starts from rest. So that means its initial speed of velocity is 0 and it accelerates at 2 meters per second square for 10 seconds. Okay, so we know that in a velocity time graph, acceleration is equals to the gradient. Okay, so I know that for first 10 seconds, okay, V minus U over T equals to A, right? So A is acceleration. I know that it is 2 meters per second square. This velocity, I don't know. Let me keep it as V. It starts from rest, so it starts from 0 meters per second, and it took 10 seconds. So I know that at 10 seconds, the velocity is equals to 20 meters per second. Okay, so here is 20. Next, it then travels at a constant speed for 30 seconds. If it's a constant speed, it is a horizontal line. Okay, and for 30 seconds, so from here to here is 30 seconds. So in other words, this portion here is 40. Finally, it decelerates over a period of 20 seconds. Oops, maybe I should draw it a bit smaller. Okay, so let me first mark out 10, 40, and 60. Okay, so maybe 10 is here. Okay, so initially 0 to 20 meters per second in 10 seconds. Next, from 10 to 40 seconds, its speed remains constant. Then it uniformly decelerates over a period of 20 seconds. So for the next 20 seconds, it is a straight line. Okay, pardon me, these are all straight line. I'll write it as STR. These are all straight line. All right. Okay. So maybe. Okay. Let me. Okay. See, my freehand drawing isn't very good, but it's a straight line that goes to 0. Okay. So now this is the velocity time graph for this motion. All right. So with that, let's go on to the next part. Okay. Find the total distance traveled by the car. So when you have a velocity time graph, to find total distance, you'll find area under the graph, right? Which is given by this trapezium here. So the area of a trapezium is half times the sum of the parallel sides. So from here to here is 30. Here to here is 60, multiplied by the height of the trapezium, which is 20. So the total distance is 900 meters. Let's move on to question 2. In question 2, you are given two forces of magnitude 20 newtons and F act at a point P in the direction shown in the directions shown in the diagram. Given that the resultant force has no component in the y direction, so this is the y direction, calculate the value of F. So F is already in the y direction. Everything is in the y direction. But for this 20 Newton force, we can resolve it into the horizontal component and the vertical component. And the vertical component is in the y-axis, right? So remember, whenever you have an angle and you want to resolve it here and here, if this angle is here, the part that you want to resolve, okay, that is with this angle is cosine. So if here is 20 Newton, here is, sorry, this portion here is 20 cosine 60 degree. And the part that is opposite to the 60 degrees will have sine. Okay, you can remember it as this. I can redraw it as this right angle triangle here, where this length here is the same as this length here, right? These two lengths are the same. This length here and this length here are the same, right? Okay, and here is 60 degree, and I have the hypotenuse, which is 20 newtons. So using your sine, 60 degrees equals to opposite over hypotenuse, which is 20. Your opposite is 20 sine 60 degree. So therefore here is 20 sine 60 degree. Okay, then this adjacent, which we do not need for this question, okay, over the hypotenuse is equals to cosine 60 degree. All right, so coming back to this question here, we want the vertical component, or we want to resolve this 20 newtons in the y direction. So the resolve 20 newtons in y direction, you will have 20 sine 60 degrees. Okay, so it is basically 20 times root 3 over 2, or 10 root 3 newtons. All right, so since F, right, and this 20, there is no resultant component in the y direction, that means F must be, the magnitude of F is 10 root 3 newtons. Okay, all right, let's move on to part B. So in part B, you are told that F is 10 newtons and find the magnitude and direction of the resultant force. Okay, so to do this, what we will do is we will resolve the 20 Newton force into the x and y direction. Okay, so we can find the resultant, okay, force in y direction, and that would be equals to, we know that this is 20 sine 60 degrees, the vertical component, then here is 20 cos 60 degree. Okay, so resultant force in y direction will be 20 sine 60 degrees minus F, which is 10 newtons. Okay, and we know that 20 sine 60 degrees is 10 root 3. Okay, so that's the resultant force in the y direction, and we know that because 20 sine 60 degrees is 10 root 3 and this is 10, so this is bigger, so we know that it is acting in the upward direction. Okay, next, resultant force in x direction. Okay, and because there's only one resultant, there's only one force that contributes to the x direction, so and is acting towards the right, so we know that the resultant force in the x direction is acting towards the right. Okay, and it is equals to 20 cosine 60 degrees, which is equals to 20 times half, or 10 newtons. Okay, so now let's find magnitude of resultant force. So the magnitude of the resultant force is basically square root of the square of the force in the x direction plus square of the force in the y direction. Okay, so I'll put it into the calculator and then round it off to 3 significant figure. So it's 12.4 newtons. Okay, next, to find the direction of resultant force, I will use tangent inverse y, which is 10 root 3 minus 10 over x. So I'll get an angle of 36.2 degrees when rounded off to 1 decimal place. And because the resultant force in the y direction is here, acting upwards, okay, the resultant force in the x direction is acting this way. So this angle here, this 36.2 degrees is above the, is about the positive x-axis. Okay, I count it from here. Okay. So now let's draw out the force diagram again. So I'll draw my slope, okay, 1.5 degrees. Sorry, not 1.5. How many degrees? 12 degrees. 12 degrees. Okay, I'm going to draw the bobsled as just this. Okay, now I'm going to draw out maybe the weight. The weight is W, which is mg. Okay, I'm going to resolve it into two components, here and here, right? Okay, if you look at this, this angle here is 90 degrees minus 12 degrees. So you can draw it down. This angle is the same as this angle. So it's 90 degrees minus 12 degrees. Okay, which is 78 degrees. So this angle here is 78, sorry, is 12 degrees here. So just make it nicer. I'll just write it as, oops, okay, never mind. Let me draw it bigger. So this one is W. Let me call this X and here be Y, okay? This is YX and this is this one here is WY, okay? And I know that this angle here is 12 degrees. You can look at it as this is my triangle. Here is 12 degrees. Okay, then I draw this here and I draw this here. Here's 90 degrees, right? Here's also 90 degrees, right? So this angle is, sorry, this 12. What am I writing? So here is 90. So if you look at this right angle triangle here, this angle here is 90 minus 12. This is also 90 degrees. So here is 90 minus whatever is here. So that's why here is 12. All right. Okay, now that we have this, okay, I know that the block sled is not moving in the x direction, right? Why? Well, I know that it is because Wx and the normal reaction force, which is R, cancel each other. So I know that the normal reaction force is equals to the y component of the weight. Okay, the magnitude of R is Wy, And Wy is equals to weight times cosine 12 degrees. And the weight is equals to mg, right? mg cosine 12 degrees. Okay. And the weight, sorry, the mass, did they give me the mass? No, they did not give me the mass, right? So let me just keep it as mg cosine 12 degrees. Okay, I'll be able to cancel it later on. Okay, so why do I want this? This is because I want to find the friction, right? Because they give me the friction between the bobsled and the slope is 0.03. So if I let F be friction, so this is my friction force. So my frictional force is equals to the coefficient of friction, which is mu times r, right? Which is equals to 0.03 mg cosine 12 degree. Okay? Okay, so this is my friction. So next, I do know that my resultant force is along the x direction. Okay, so the resultant force, let's resolve it, is equals to Wx minus F. And Wx is essentially mg sine 12 degrees. Okay, then the F here is 0.03 mg cosine 12 degrees. Okay, and we know that resultant force is equals to m times a, right? So we can find what is a from here. So we know that we can cancel off all the m, right? So therefore g sine 12 degrees minus 0.03 g cosine 12 degree equals to a, and g is 10 meters per second square. Okay, let me find a. So a is 1.7856 or 1.79 meter per second square. Okay, but do we want a? No, we are asked for the time taken for it to reach the bottom of the slope, right? Okay, so next let's do this. So we have the distance, which is 60 meters. So we know that the S, so we are going to use our kinematics equation. So S, which is the displacement, is 60 meters. A is 1.7856 meters per second square. Okay, I want to find T, right? What else do I have? Okay, so it starts at the top of the slope with 5 meters per second. So I know that the initial speed is 5 meters per second. Okay, so I will use the formula S equals to UT plus half AT square. Okay, I also have V equals to U plus AT. I also have V square equals to U square plus 2AS. But I don't have V, right? So I will not use any of them here. Okay, because I only have the starting speed, which is U. I did not have V, so I will not use any of the other kinematics equations. I'll use this. Okay, so I know that S is 60, U is 5, I don't know what is T, I need to find it, plus half. A is, I will use 1.7856, then T square. It's a quadratic equation. So it is 0.8928 t squared plus 5t minus 60 equals to 0. To find dt, use your quadratic formula, minus t minus 5 plus minus 5 square minus 4, 0.8928 times minus 60 over 2 times 0.8928. Okay, so let's just evaluate this using the calculator. Okay, so I'll get positive 5.8626 seconds. Okay, or I also have a negative one which I need to reject. Which is negative 11.463. So I will reject since time cannot be negative. So therefore my t equals to 5.86 seconds when rounded off to 3 significant figures. Let's take a look at question 6. So in question 6, you are told that a particle moves in a straight line starting from point O. The velocity of the particle at time t seconds after leaving O is v meter per second. So from the first sentence, right, a particle moves in a straight line starting from point O. That means when t equals to 0, its displacement is 0 because it's at point O. The velocity of the particle at time t seconds after leaving O is v meter per second. So this is the equation for the velocity, where k is a positive constant. Okay, the maximum velocity is 4.5 meters per second. Okay, show that k equals to 10. So let t be equals to alpha when v is equals to v max. So I know that because v follows this equation, so I know that when v is 4.5, t is equals to alpha. Okay, but I have two unknowns, so I cannot solve. I need another equation. So how do you find maximum v? Well, to find a maximum point, we will find what is dv dt, equate it to 0. Okay, because at maximum point, your dv dt is 0. Okay, so let us differentiate v. So when I differentiate v, I get a. Do I need a later on? Not really, but it's okay. Okay, so v is equals to half k t to the power of minus half minus 2. Okay, when dv dt is equals to 0, I know that half k t to the power of minus half is equals minus 2 is equals to 0. Okay, so k over 2 root t is equals to 2. So this one can be rewritten as this, okay, because t to the power of minus half is equals to 1 over root t. Then I bring 2 over. Now I do a cross multiplication, so I have k equals to 4 root t. So therefore, root t is k over 4, and therefore t is k squared over 16. Okay, so I'm going to sub 2. Okay, so this is what I have, and I know that when dv dt equals to 0, t is equals to alpha, right? Because when dv dt is equals to 0, we are at stationary point, which is the v max. Okay, so I'll sub in t as alpha. Okay, so I will sub 2 into 1. Okay, so I have k times k squared over 16, okay, to the power of half, minus 2k squared over 16 minus 8, okay? So square root of k squared over 16 is k over 4, then times k, so I have 1/4 k squared. So this here is equals to 1 over 4k squared. Then next, this will be equals to 1 over 8k squared. Okay, minus 8 minus 4.5 equals to 0. So this 25 over 2. Oh, okay, wait, let me combine 1 over 4 minus 1 over 8. I'll get 1 over 8. Okay, so k squared is equals to 25 over 2 times 8, or k squared is equals to 100. K is equals to square root of 100, which is 10. Okay, reject negative 10 since k is more than 0. Okay, so therefore k is equals to 10, and we have shown what we need to show. Okay, so that is for part A. Moving on, you need to verify that v equals to 0 when t equals to 1 and t equals to 16. So again, basically, sub in v equals to 0, get into the equation. V equals to kt to the power of half minus 2t minus 8. Minus 8, right? And we also know from the first part that k is 10. So instead of writing k, I'm going to change it to 10. Okay, so now when v is 0, okay, I have 10t to the power of half minus 2t minus 8 is equals to 0. Since they asked me to verify, so I can sub t equals to 1 into equation 1. Okay, so I have t 10, 1 to the power of half minus 2 times 1 minus 8 is equals to 0. Okay, therefore, when t is 1, v is 0. Next, I'll sub t equals to 16 into equation 1. So 10 times 16 to the power of half minus 2 times 16 minus 8, okay, is equals to 10 times 4 minus 32 minus 8. So minus 32 minus 8 is minus 40. 40 minus 40 is 0. So when t is 16, v is equals to 0. Therefore, we know that when v is 0, t is equals to 1 and t equals to 16. So we have verified this. All right. Okay, with that, we are going to move on to the next part, which is on distance. Okay, so find the distance traveled by the particles in the first 16 seconds. Okay, so we are going to find displacement. Displacement is the distance from O. It is not distance. So we need to do some things, right, in order to determine that. So the reason why they ask us to find what is the value of t when v is 0 is because we know that at v equals to 0, okay, it is the point where the velocity will change from positive to negative or negative to positive, and that means it's going to change its direction. Okay, but before we do any of that, let's first find what is the displacement. Displacement is v dt. Okay, so let's first integrate v, which is 10 t to the power of half minus 2t minus 8. Okay, and we know from here, from first part is that when t is 0, s is 0. So let's put in. Okay, so we know that c is 0. So therefore, we know that s is equals to 10 divided by 3 over 2, which is 20 over 20 over 3, t to the power of 3 over 2 minus t squared minus 8t. All right. So with that, what we need to do is we need to find what are the various s, right? So let's draw it out. So I have t equals to 0. I know that s is 0. Okay, I also need to know, I know that it's going to turn. Okay, it is going to turn at t equals to 1 and t equals to 16. And t equals to 16 is also where it stops moving. So let us find s at these 3 points. We already know that t equals to 0, s is 0. So this is the starting, this is the ending, and also we need to include when it turns. Okay, so it starts at 0 seconds, it ends at 16 seconds, and it turns at both 1 and 16 seconds. So let's find what is s. So I know that s when t is 1 is 20 over 3 minus 1 minus 8. So it's negative 2 1/3 meters. Okay, do the same for t equals to 16. So we have 42 2/3 meters. So with that, let's sketch out how it is moving, right? So it is initially at t equals to 0. Okay, at t equals to 0, and this is the reference point. Maybe let me sketch it with a different color. Okay, this is O. So I know that at t equals to 0, the particle is here, right? It's here. Then at t equals to 1 second, it is at negative 2 1/3 meters. Its displacement is negative 2 1/3 meters. When you have a negative displacement, it just means that it's at an opposite direction to O compared to the positive. So if I take this direction as positive, then this direction will be negative. So negative 2 1/3 meters will be here. So this is at t equals to 1. So here the displacement is negative 2 1/3, right? Negative 2 1/3. Okay, meters. And I know that the distance we ignore the negative sign, is 2 1/3 meter here. So from here to here, it moved 2 1/3 meters. So it moves from here to here. So it has traveled 2 1/3 meters. Then at t equals to 1 second, it will change direction, right? So initially it was moving to the left. Now it should be moving to the right. And then all the way until t equals to 16 seconds, it is here. We know that it moves all the way to here, right? So from t equals to 0 to t equals to 1, it moved 2 1/3 meters. Okay? From t equals to 1 to t equals to 16 seconds, it moved this plus this. So it's 2 1/3 meters plus 42 2/3 meters. So to find total distance traveled, okay, we will first take 2 1/3 meters, which is the distance traveled in the first 1 second. Then plus 2 1/3 plus 42 2/3, which is the distance traveled, okay, by the particle between t equals to 1 to t equals to 16 seconds. Now let's add up everything. Which we get 47 1/3 meters. So the total distance traveled will be 47 1/3 meters, or 142/3 meters. Okay, so let's move on to question 7 now. A particle of mass 0.2 kg is projected vertically upwards from the horizontal ground with a speed 25 meters per second. Show that the speed of P when it reaches 20 meters above the ground is 15 meters per second. So we know that this is a particle. Okay. So it is moving upwards, right? So this is P, is moving upwards. Initial speed is 25 meters per second. So after moving 20 meters, so after it is displaced upwards by 20 meters, they are asking find what is V. Okay, so we want to find V. We have initial speed, which is 25 meters per second. We have displacement, which is 20 meters. Okay, we also have acceleration because it's moving upwards, right? So it is negative g, which is negative 10 meters per second square, because when you're moving up, it's decelerating. Okay, so how do we find v? We'll use v squared equals to u squared plus 2as. All right, so u is 25. Okay, 2 minus 10, 20. Okay, so we can find what is v squared. Okay, so v squared is 225. So v will be square root of 225, which is 15 meters per second. Okay, next, when P reaches 20 meters above the ground, it collides with a second particle Q of mass 0.1 kg, which is moving downwards at 20 meters per second. P is brought to instantaneous rest in the collision. Find the velocity of Q immediately after the collision. So let's look at it as at s equals to 20 meters, okay, before collision. So before collision, P is moving upwards, right, at a speed of 15 meters per second, and P has a mass of 0.2 kg. Q is moving downwards, okay, at a speed of 20 meters per second, and it has a mass of 0.1 kg. After collision, P stops moving. So the velocity of P after collision is instantaneous rest, so it's 0 meters per second. Okay, for Q, okay, it will still be moving, right? So we are going to find what is V. Okay, and we know that the m still remains at 0.1 kg. So this one is the momentum, right? Conservation of momentum. And I want to let going downwards as positive, okay? So in other words, right, 20 meters per second is positive, okay? 15 meters per second is negative, okay? So I want to take downwards motion as positive, okay? So in other words, right, this P will have a negative velocity, okay, before collision because it's moving upwards. This Q will have a positive velocity because it's moving downwards, okay? So I know that mass of P times initial velocity of P plus mass of Q plus initial velocity of Q must be equals to mass of P, a final velocity of P, plus mass of Q, final velocity of Q, okay, by conservation of momentum. So sum of momentum before and after must be equal. So let's put in, so mass of P is 0.2, then minus times minus 15 plus 0.1 times 20 equals to 0.2 times 0 because it's instantaneously at rest for P plus 0.1 times VQ. So I need to find what is VQ. And VQ is negative 10 meter per second. Okay, so in other words, right, Q is moving, so it's negative, that means it's moving upwards with at 10 meters per second, okay, after the collision. Next, let's move on to C. When P reaches the ground, it rebounds back directly with half of the speed it had immediately before hitting the ground. Find the height above the ground at which P and Q next collide. Okay. So now let's take a look at part C. We are told that when P reaches the ground, it rebounds back directly upwards with half of the speed that it had immediately before hitting the ground. Find the height above the ground at which P and Q collide. So we know that immediately after the collision, P is moving downwards, Q is moving upwards. Okay, so as P is moving downwards and Q is moving upwards, there will be no collision. So the first thing we need to know is how long does it take for P to reach the bottom. Okay, then we need to find out at this point in time, right, where Q is. So we know that after the collision, P has a speed of 0 meter per second. It is moving downwards, so it's accelerating at 10 meter per second square. Okay, and the distance above the ground is 20 meters. So I need to travel 20 meters downwards. Okay, so how long does it take for P to reach the bottom? Well, I know S is 20, A is 10, and U is 0. So let's use S equals to UT plus half AT squared to determine how long does P take to reach the bottom. So let me sub it in. 20 equals to 0 times T, which is 0, plus half 10T squared. So for T, I'll get T equals to 2 seconds. So I know that at 2 seconds, P will be at the ground. Now, let's find out how about for Q, where is it at 2 seconds? So I know that Q is moving at a speed of 10 meters per second upwards. Okay, and because it's moving upwards, it is having negative acceleration. All right. So how long does Q take to reach the highest point. Okay, so I know that at the highest point, okay, the velocity is 0. So let's find out when v is 0. Okay, this is for q, for p. When v is 0, I know that using v squared equals to, no, just v equals to u plus at. V is 0, u is 10, and a is -10. I know t is 1 second. So v takes 1 second to reach the top. So if q takes 1 second to go from this point here to the highest point, it will also take 1 second to go from the highest point to this point here, which is 20 meters above the ground. Okay, so since q takes 1 second to go from 20 meters above ground to highest point, okay, when it reaches the highest point, the velocity is 0, so by gravity it will start to move downwards, right? Okay, and because going up is 10 meters per second square, coming down is 10 meters per second square. Okay, sorry, going up is -10 meters per second square, coming down is 10 meters per second square. The magnitude of the acceleration is the same. So therefore, if it takes 1 second to go up, it will take 1 second to come down to the same distance. Okay. Okay, it will also take 1 second to go from highest point to 20 meters above ground. So in other words, right, it takes 2 seconds to go from 20 meters above ground to highest point and back. That means in 2 seconds, Q went from here, 20 meters, or from where they collide to the highest point and then come down. It took 2 seconds. It also took 2 seconds for P to reach the ground. So at 2 seconds after collision, we know this, right? P is at the ground. Let's just assume that this line here is the ground. Okay, this is P. And Q is here, which is 20 meters above the ground. Okay, and Q is going downwards and P is going upwards. Okay, so because they are moving towards each other, they will be able to collide. They will collide. And when will they collide? They will collide when the total distance traveled by both of them is equals to 20 meters. Okay? So let T1 be the time when P reaches the ground. The time after P reaches the ground. So I'm going to reset my timer. T1 is equals to 0 when P is at the ground and Q is at 20 meters above the ground. Okay, so do I know what is the speed of P at this point in time? Well, I can find it from here, right? I can use V equals to U plus AT. So at 2 seconds and A equals to 10 and U equals to 0, I know V is 20 meters per second. So when P hits the ground, its speed is 20 meters per second. But when it rebounds up, is the speed still 20 meters per second? No, because the question says that its speed is now half of what it was when immediately before hitting the ground. So I know that at T1 equals to 0, the speed of P is 20 times half, which is 10 meters per second. Okay? At T1 equals to 0, I know that Q is the initial speed of Q is 10 meters per second. Because it's moving down, it's accelerating at 10 meters per second square. And because P is moving upwards, it is accelerating at negative 10 meters per second square. Okay? So, the displacement of Q from this position here is given by U times T plus half a T square. Okay? The displacement of P from this point here will be given by U times T plus half a T square. When they meet, SQ plus SP is equals to 20, and they meet at the same point in time, so the T must be the same. Okay, so this one should be T1. Okay, so let's find what is T1. Okay, and from there we can find the how far P is above the ground. Okay, so let's, sorry, it's 20 meters. Yeah, so we know that 10, so T1 plus half times 10 times T square is 5 T1 square plus 10 T1 minus 5 T1 square is equals to 20. So 20 T1 is equals to 20. So T1 equals to 1. So they meet 1 second after P reaches the ground. And then the distance of P above the ground is 10 times 1 plus half times negative 10 times 1 square, which is equals to 5 meters. So therefore, when they meet, they are 5 meters above the ground. Okay, why I use SP instead of SQ is because the Q starts counting the distance from this top here. Okay, so it will, if I will take SQ, I will sub in T1, then I need to take 20 minus SQ to find distance above the ground. That is why I use SP.